focus today is going to be on predicting products of chemical reactions. So this will be the last video for this unit. Now, one of the things that you're going to need to understand is that this is a combination of what we have learned realistically in the previous two videos. Being able to understand what type of reaction is present is absolutely crucial to being successful at predicting products of chemical reactions. Additionally, we also need to make sure that we know how to do proper nomenclature as well as to be able to balance chemical equations. The goals for today are very simple. You should be able to predict products of any chemical reaction I give you. And some key vocabulary terms for this particular unit include the word diatom. Now, we've already talked a little bit about diatoms, but meh. So, keep in mind that when we talked about predicting products, again, this is a combination of everything that we've learned so far. So we need to make sure that you understand nomenclature. You need to know how to write chemical formulas to be successful at predicting products of chemical reactions. You also need to understand reaction types, as well as being able to balance chemical equations. So everything kind of comes together when we're trying to predict the products of a chemical reaction that will take place. So what steps are necessary to predict products of chemical reactions? Well, Step 1 states that based on the reactants, we determine the reaction type. So you remember, if we have, an element plus an element, then it's going to be synthesis. Or if we just have one compound to the left of the arrow, we know it's decomposition. An element plus a compound is more than likely single displacement. Two compounds are going to be double displacement. And a hydrocarbon plus oxygen is going to be combustion. Step 2 is to write out the simplest product form based on the reaction type. So if you remember, we talked about how synthesis, for example, is A plus X yields AX, or decomposition AX yields A plus X. We need to write our product in the simplest form. Step 3 is then correctly write out each chemical in our products using the nomenclature rules that we've talked about. And when we're done, we should be able to go through and balance our chemical equation. So lots of different steps that are required for this, but if you're good with these, then you should have no problems balancing chemical equations. Now, one thing that we've already discussed that I want to talk a little bit more about is the concept of diatoms. Some elements cannot exist by themselves. So, for example, hydrogen. Hydrogen by itself cannot just be H. It will always be H2. Nitrogen, N2, oxygen, O2, etc. Now, keep in mind that if they are in a compound, you will always follow the correct nomenclature rules to determine how many atoms of each thing are in the compound. However, when they are by themselves, they are always whatever the element is in the subscript of 2. The way I remember this is use Brinkelhoff. Brinkelhoff is just kind of a short little acronym that helps you remember all of the different elements that are diatoms. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. And all of those elements on their own exist as diatoms. Keep in mind, diatom, di means 2, atom means, well, atom. So these are atoms that appear as 2. So let's predict some products of some chemical reactions. We have AgCl, or silver chloride, reacting with aluminum. Well, step 1 is to determine what type of reaction is taking place. So if we look, we have a compound plus an element, so we know that this is single displacement. Okay, now if we remember when we talked about single displacement reactions, we need to look at the element and what is it going to replace. So we have aluminum here. Is aluminum going to replace the silver or the chlorine? Well, if you remember, we talked about how like replaces like. Metals will replace metals and non-metals will replace non-metals. So in this case, the aluminum is going to trade places with the silver. So when we write this out, we're going to have AgCl plus Al. And remember, we were told to write the simplest form of our products. That means no subscripts unless it's a polyatomic ion. So we're going to switch places here. So we're going to have AlCl plus Ag. Now we need to make sure we write our products correctly. Silver by itself is perfectly fine. Al is a +3 charge. Cl is a -1. So to write this correctly, we need to put a 3 down next to AlCl. Now we can go in and balance the rest of our equation, since we've written our chemicals correctly. Aluminums all balance out, silvers balance out, but we have 3 chlorines to the right of the arrow. We have 1 chlorine to the left of the arrow, so we need to place a 3 in front of AgCl. As a result of that, that changed the number of silvers, So we need to go back to the right-hand side and put a 3 in front of Ag. And now our equation's balanced. All right? So again, the idea here, make sure you understand step 1, determine what type of reaction takes place. Step 2, predict the basic forms of your products. Step 3, use your nomenclature rules to write your products correctly. And then lastly, balance your chemical equation. Let's move on to the next one. Aluminum sulfate reacts with potassium chloride. Well, now we have to write our reactants out. So let's go ahead and do that. Aluminum, Al, sulfate is SO4 plus 3 minus 2. So this is Al2 SO4 3. Reacts with potassium chloride. KCl plus 1 minus 1. So they cancel. All right, now taking a look at this, we have a compound plus a compound. So the first thing we need to do is identify this as a double displacement reaction. All right? Remember, in our double displacement reaction, all we simply do is we switch out our anions. So here we're going to have chlorine and sulfate trade places. So sulfate is going to go with chlorine, and they're going to trade places. So when we predict our products, it's going to be AlCl plus K SO4. Again, write the simplest form of your products, keeping in mind that subscripts only occur with polyatomic ions. Let's go ahead and write our formulas correctly. So you have plus 3 minus 1, so this is AlCl3. KSO4, we have plus 1 minus 2, so it's going to be K2SO4. So now that we've written everything correctly, we need to just go through and balance our equation. So let's take a look at sulfate. There are 3 SO4s to the left of the arrow. There's 1 to the right of the arrow, so let's put a 3 in front of here. That gives us 6 total potassiums. So here we need to put a 6. That gives us 6 chlorines, 3 on the right side, so we need to put a 2 there. And that gives me 2 aluminums and 2 aluminums. So my equation is completely balanced. And I'm done. Okay? So again, just like I said before, make sure you determine the reaction type. Make sure that you write out the basic forms of your products based on the reaction type. Use your nomenclature rules to write your products correctly. And then go through and balance your chemical equation. Let's do one more sample problem. The very last sample problem we are going to conduct is the combustion of propane. Now, what's nice is that this actually makes it fairly easy because we already know that this is a combustion reaction. And if you remember what we've talked about with combustion, it is a hydrocarbon, in this case, propane. It always reacts with oxygen to produce carbon dioxide and water. So it's actually pretty straightforward here. So then we know our products are written correctly because they're always the same products. So step 1, again, this is a combustion reaction. We've already done 2 and 3, so we can check those off. The next thing we need to do, we've already done 2 and 3, so now we just need to balance our equation. Remember what we talked about with combustion. Carbon, hydrogen, oxygen. 3 carbons to the left, 1 to the right, 3 goes in front. Hydrogens, 8 and 2, so a 4 goes there to make that 8. Our total oxygens are 6 and 4, which is 10. So we need a 5 in front of O2 in order to balance our equation. So that's pretty much it. Again, just make sure you determine the reaction type, predict the basic forms of your products, do your nomenclature rules, and then balance your chemical equation. Long story short, for our last video of the unit, again, follow each of the 4 steps to ensure that you correctly predict the products of every chemical reaction. Yes, I realize that's incorrect grammar, but that's okay. You can make fun of me for my incorrect grammar the next time you see me in class. It's okay. I'm a science teacher. My grammar is not good-ish. I think you got the learning targets for this video. If you have any questions, let me know. Other than my horrible grammar, you can get over that. We'll see you next time. Have a great day, guys, and we will talk to you later. Bye-bye.